onto homomorphism. So till now we have got like what is homomorphism, how to define an homomorphism, how to check whether homomorphism exists or not. Then we work on like to count how much, I mean, number of homomorphisms. Okay, now it's time to learn about onto homomorphism. So to call an homomorphism as onto, we must have two conditions. First, it must be a homomorphism. Second, it must be onto. Okay, so let's just take an example. Like we need to find the number of onto homomorphisms from Z6 to Z8. So first thing we need to understand, for an homomorphism to become an onto, this group must be smaller than this group. Basically, order of Z6 here is 6, order of Z8 is 8. So the mapping from the basically the group Z6 to Z8 can't be onto, because it has more element, it has less elements. So how can we map like each and every element of this to this? So hence it is not onto. Okay, second, just take an example like homomorphisms, basically onto homomorphisms from Z8 to Z4. So clearly here order of Z4 is 4. Yes, order of Z8 is 8. So since order of Z4 is less than order of Z8, we can think of onto homomorphism. Okay, onto homomorphism. So we already know that like if the mapping is from Zm to Zn, the number of homomorphism will be GCD of 8, 4, that is equals to 4. And we also know that the homomorphisms are of the form 0x, 2 of x equals to 1x, t of x equals to 2x, yes, and t of x equals to 3x. Yes, we will just check it like in में से which one is onto and which one is not. Okay, so let's just, so here I have just made the like groups, like first one is Z8, second one is Z4. Okay, so we have the homomorphism possible as 0x, 1x, 2x and 3x, and we need to check out of them basically which one is onto or not. Okay, so in one case what we have is t of x equals to 0x, that is all the mappings are mapping to 0, all the elements are mapped to 0. So clearly in this case we are not having any preimage to 1, 2, 3, that is why it is not onto. Okay, because we have not preimage of 1, 2, 3. In second case, t of x equals to 1x. So in 0 is mapping to 0. Okay, 1 is mapped to 1, 2 is mapped to 2, 3 is mapped to 3. Then 4 will map to what? So as we are having like groups are Z8 and Z4, so basically 4 in Z4 is equals to 0. So 4 is again mapped to 0. 5 is equals to 1 in Z4, that is why it is mapped to 1. 6 is mapped to 2 and 4 is mapped to 3. So hence every element has a preimage, that is why it is onto. Okay, in the case of 2x like definition is like tx equals to 2x. So 0 is again 0, 1 is mapped to 2, 2 basically 2 2s are 4, and 4 in Z4 is 0, so 2 is again mapped to 0, 3 2s are 6, and 3 2s are 6, and 6 in Z4 is 2, then it will map to this. 4 2s are 8, and 8 in Z4 equals to 0. Okay, so in this manner like we are getting values 5 2s are 10, 10 in Z4 is 2, this is mapped to this. 6 2s are 12, and 12 in Z4 is 0. Okay, and 7 2s are 14, 14 in Z4 is 2 again. So here we are clearly getting it as like 1 has no pre-image. Yes, so hence it is not onto. It is not onto. Last case, t of x equals to 3x. So t of x equals to 3x, basically 1 and 3 both are not getting any preimage, so it is not onto. 0 is mapped to 0, 1 is mapped to 3, 2 is mapped to 2 3 is 6, and 6 in Z4 is 2, so it is like this. 3 3 is 9, and 9 in 4 is what? 1. Yes, so basically we are having images for every 0 1 2 3 element, so hence it is onto. So only possible onto homomorphisms from Z8 to Z4 are t of x equals what? 1x, and t of x equals to 3x. So in this manner we can check out the onto homomorphisms. In next video we will check out the trick we can use to directly get the number of onto homomorphisms. Okay.